Hi there, I'm Brendan Burns, CVP for Azure Resource Manager and DevOps in Azure. Have you been wondering the best way to describe and deploy resources to the Azure cloud? Well, the modern cloud-native way to do development and deployment of Azure resources is Infrastructure as Code, or IAC. With Infrastructure as Code, you use a simple text format to describe your resources, and then you can take that description and use it to reliably and repeatedly deploy your application around the world. Now, traditionally, infrastructure as code languages have been a little complicated, hard to learn, and honestly, not that much fun. With Bicep, a new infrastructure as code language from Azure, we've put a real focus on designing a language that's easy to start with, fun to use, and has great tooling in familiar environments like VS Code. Whether you're a beginner in the world of infrastructure as code or you have a bunch of experience in ARM templates, we invite you to join us on Microsoft Learn Live. There, we're going to have a series of lessons with subject matter experts on the Bicep team, helping you understand the best way to use Bicep to do infrastructure as code on Azure. Along the way, you'll learn Bicep basics, get to know the tooling in VS Code, and even learn a lot about Azure resources along the way. We're inviting you to come and enjoy this free learning experience in a series of weekly lessons starting Tuesday, March 8th, 2022. We hope to see you there.
Hello, everybody, and welcome to Learn Live. And most importantly, welcome to the first episode of a new series on using Bicep to deploy your Azure infrastructure as code. Over the course of the next few months, we're going to take you through 15 episodes of content covering everything from the fundamentals of Bicep through to advanced Bicep topics. I'm one of your hosts, John Downs, joining you from New Zealand, where it's bright and early this morning. And I'm a customer engineer in the Fast Track for Azure team. So I focus a lot on application development and customers who are building applications on Azure, as well as DevOps and solution architecture and some other things. And joining me today from somewhere that is much more civilized time than it is here in New Zealand is my colleague and friend, Josh. Hey, Josh.
Hey, John, and hello, everybody. Great to be here today. My name is Josh Waddell. I am also a customer engineer, but on a different Fast Track team. I'm on the Fast Track for Azure for ISV and Startups team. I'm actually in St. Petersburg, Florida. My main area of focus is in the Azure infrastructure space, but I do spend a lot of time on infrastructure as code and specifically Bicep. John and I have had many conversations over the course of the last couple of years around IAC and Bicep. So it's great to be here with everybody. So we've got a lot of fantastic content coming for you over the course of the next 15 episodes, as John has mentioned. Today is the first episode in our series, and it is on Introduction to Infrastructure as Code using Bicep. So with us today is Will Valita. Will is going to be our moderator. Everybody say hello to Will. So he's going to be in the chat. He's going to be answering your questions and also passing along some of those questions to myself and John. So feel free to interact with Will in the chat.
Awesome. So this content today is based on a Microsoft Learn module. And the Learn module is, of course, titled Introduction to Infrastructure as Code using Bicep. So if you want to follow along with the Learn module, or if you want to have a look at it later or share it with your friends, then the link to it is at the top there, that aka.ms link. And of course, if you're not familiar with Microsoft Learn is an awesome place to learn about a whole lot of different Microsoft technologies. And of course, it's interactive experience. You can follow along with lots of interesting demos and see how things work. It gives you enough context to understand why things work the way that they do and how to use them. And you can also practice and apply learning those new skills as well. So please take a look at that Learn module when you get a chance. So today's module has a few learning objectives. Now, today's session, we should point out, is an introductory session. So we're not going to go deep into Bicep today. We will talk about it, and we will talk. Josh will show some cool demos of just some really basic Bicep code. But basically today we're setting the scene, right? We're explaining how infrastructure as code works and why you might want to use it in your organization if you aren't already, especially. So the learning objectives for today are firstly to talk about the benefits of infrastructure as code. Josh and I are huge proponents of infrastructure as code. We spend a lot of time talking to customers about why it's a good idea. We want to give that little pitch to you as well. And if you're coming at it from a perspective of having never worked with infrastructure as code, Or if you have to try and sell that internally in your organization, then hopefully there'll be some good information there that you can use to help to describe those benefits. We're also going to talk about the difference between two different kind of broad models of infrastructure as code, declarative and imperative. And so Josh will talk through some of that later and give some demos as well. And then with that kind of context set, we're going to talk about what Bicep is and how it fits into an infrastructure as code approach and how it's used within Azure.
All right. So let's jump into the introductory section of this particular module. So if you're going to tune in with us over the course of the next 15 episodes, we are going to utilize a scenario over the course of all of this content. And this scenario is going to tie into each of the smaller discussions that we have. So the scenario for this series is you are working as an infrastructure administrator, an Azure infrastructure administrator at a toy company that's experiencing some significant growth. Your team is finding that you're having to deploy new applications, both for internal teams and customers. You're doing multi-regional deployments to make these applications available around the world for your customers and partners. And you're also doing multiple environment deployments to help strengthen the consistency. So we're talking about production environments, development environments, test environments, QA environments, and so forth. So kind of highlighting on some of the objectives in this particular section, we're going to be talking about, or in this particular module, I should say, we'll be talking about what actually is infrastructure as code. How do we define that? How can it help you automate your resource provisioning? How can it help you build those resources inside of Azure, regardless of the method that you use? We'll talk a little bit about Bicep and how it works. And when should you use Bicep instead of some of those other options that are available? So in regards to the main goal of this module, the main goal is you're going to be able to determine whether or not infrastructure is code, or you may hear us say IAC over the course of this discussion, whether or not IAC is the right approach and tool for your organization. All right. So when we talk about what infrastructure as code is, diving back into the scenario a little bit, you've been asked to evaluate whether IAC might be a valuable approach to deploying resources at your company, right? With this massive amount of growth, you're finding that more and more deployments are needing to be done perhaps on a daily basis or a weekly basis. So you need some way to kind of automate that process with a repeatable option. And some of the things that we're going to kind of talk about today within infrastructure as code are going to be some of these things that you see here in these bullet points. We're going to be talking about ways that we can deploy our infrastructure to Azure, either using the Azure portal, using command line interfaces like the Azure CLI, using the Azure PowerShell. And then we're going to also be talking about ARM templates, both from a JSON perspective and a Bicep perspective. Okay. So another way that we can think about infrastructure as code, and we'll tie this back into the scenario here, right? Your company, again, is designing new toys for release to market. If you are a parent, or perhaps you remember from your days as a child, a lot of toys that you received, you had an instruction manual. Some toys had some, assembly required before you were able to use them. You can think of infrastructure as code as being like that instruction manual for your infrastructure. IAC,
can I just interrupt for a second, Josh,
absolutely.
and say that hopefully, as speaking as the parent of a 3-year-old who has a lot of toys that required instruction manuals, hopefully infrastructure as code is going to be a lot clearer and a lot less difficult to follow than the instruction manuals that I've been using.
Absolutely. Absolutely. No, I agree with that completely. So you can think of IAC as kind of like that instruction manual for your resources. It defines all of the steps and all the procedures to build those particular resources inside of Azure. So with that being said, John, can you define for us what IAC is?
Yeah, sure. So, I mean, essentially, the term infrastructure as code is a really nice definition in itself, right? It's a way of defining your infrastructure, your Azure resources in code, right? And it's similar to how software is deployed. So if you're writing software, if you've ever written software before, you write code in a language that's kind of readable and writable to humans, and then it's translated into something else behind the scenes and executed by the computer. It's a similar kind of idea, right? So you write your code, you write your infrastructure as code in things called templates, or what we'll talk about soon, Bicep files, and then you'll provide those to Azure to deploy. So the template defines all of your resources that you want to deploy. So in this example, you might have an app service plan. If you're working with Azure App Service, you might have application insights. You might have the app service app as well. And then Josh, if you can press enter.
Absolutely.
Thank you. You can also then automate that deployment as well. Now, we're not going to talk about that a huge amount today, or actually in this series. There is a lot of content on Learn about the automation of infrastructure as code. But basically, once you've got those assets, once you've got the templates or the Bicep files or whatever it is you're using, then it becomes fairly straightforward to create pipelines and workflows and automated processes to deploy those.
John, so
it's a really
Hey, one of the things that I get in a lot of my customer engagements around infrastructure as code, again, I'm in the infrastructure space. I know that you're in the app dev space. Customers, when we present this to them, there's a little bit of concern sometimes from the infrastructure people that maybe aren't into scripting, haven't written a lot of command line or a lot of PowerShell scripts, or even templates in that case. Is infrastructure as code just strictly for developers, or how can an infrastructure team, is it easy for an infrastructure team to get involved in?
That's an awesome question, Josh. I'm very glad you asked that. So basically, the infrastructure as code is not just for developers, right? And in fact, all of the content that's in this Learn series, in this Learn Live series, is designed for people who have never written code before.
Oh, that's good.
So even if you've never written any JavaScript, C#, Java, anything, if you want to be able to deploy your infrastructure as code, you can follow along and learn about these languages, specifically Bicep, that we're going to be talking about. There's a lot of benefits to doing it, even if you're not a developer. So I would absolutely say it's something that we encourage, cloud engineers, system engineers, anybody who's coming from a more traditional IT background. There are huge benefits to understanding this approach as well.
Awesome.
Cool. So why do we use infrastructure as code, right? We've talked a little bit about kind of what it is, but what's the reason that we would go down this path? Well, the main reason is there's some really, really significant benefits that it gives you and your organization. One big benefit is how it helps to increase your confidence in your deployments. We'll talk about this in a few seconds, and we'll explain this in a bit more detail. Also, Josh mentioned that in the toy company example that we're talking about today, they have a lot of environments, right? So they might want to have environments around different geographic regions, so deploying their solution at different parts of the world. Or they might just have development, test, UAT, staging, production kind of environment separation. Either way, they want those environments to be in sync, and they want them to be able to be easily deployed and to be consistent. So infrastructure as code will help to manage all of those environments too. And then a third benefit that I think is sometimes a little bit understated with infrastructure as code is that it helps you to understand your cloud resources better. We'll explain this a bit more later on, but it really, when you write infrastructure as code, you kind of get to know the details of the things you're deploying in a much more descriptive way than you would if you were just using the portal, for example. So one of the benefits that I mentioned is the level of confidence that you gain in your deployments, and that includes consistency and security as well. So let's have a look at some specifics here. So firstly, if many organizations already have teams that are building software, right? So those teams might be separate to the teams that build the Azure infrastructure or any other cloud infrastructure. But if you've got those kinds of consistent processes that you're using in your organization, then you can start to adopt those same processes throughout your infrastructure deployments as well. So a really good example of this is reviews. Right, so software developers are often very used to being able to review each other's code. A common workflow for software developers is that somebody will start working on a change or a feature. They'll do a whole bunch of work on that themselves, and then when they've finished, they think they've finished, they'll give it to their team members to go and review, and they'll use things like pull requests in GitHub to do that. We'll talk about that another time as well. So you can use the exact same processes with infrastructure as code. If your infrastructure is all defined as code, as a text file, then it's very straightforward to provide other people with access to that code to be able to review it, and also to integrate it into your other company's processes. Now, another big benefit is consistency. All right. So one of the interesting problems that I had with a customer about 18 months ago, I think, was that this customer was doing quite a lot of advanced things in Azure. They were deploying a lot of resources in a lot of interesting ways. But there was only one person in the company who actually understood how that all worked and was able to actually do all the deployments. Whenever he went away, and he went on leave sometimes, then the whole Azure deployment process stopped, right? Nobody understood what to do nobody understood how to deploy anything to Azure. So if you move your deployments and your Azure Azure information into infrastructure as code, then suddenly it becomes a lot easier for everybody else to follow that same process to deploy and to make changes and have all of those changes be able to propagate through to all of your different environments if you want to. You can put lots of controls around that too, but basically it means that you can get some of that knowledge out of somebody's head and put it into some code.
Hey John, on the one thing in that really stands out to me is the line there on reducing the human error, right? Doing automated deployments from either a script or from a template that's already built, that's already been reviewed, that's already been tested, versus somebody going into the portal and making those deployments, manually, right? If you've got to redeploy that virtual network time and time and time again, there's a good chance that you might, misspell, the resource name, or you may put it into the wrong resource group. Or you may not use, the right naming convention or something along those lines. Choose the wrong IP prefix for a particular subnet. So that to me is like one of the biggest things in that particular statement. There is really getting rid of that possibility of human error.
Absolutely, yeah, that's a really good point. And we'll talk about environments in a second too. But it kind of gets to the same thing where you don't want to try and have to manually deploy two different environments and keep them consistent, right? If it's very hard to do that as a human, and it's very hard to keep everything exactly the same. So having it in code and then being able to use that code in multiple places really helps with that too. And then the third bullet point on this slide is an interesting one too. So once you've got your infrastructure defined as code, and again, you'll see some examples of this shortly. Josh will show some examples of what this actually looks like in code. But when you've got your infrastructure defined as code, you can now start doing some interesting things with that, like, for example, scanning it. So we know, for example, that customers shouldn't deploy Azure storage accounts that are accessible over HTTP, right? We want them to be accessible over HTTPS only, so they're more secure. Now, if you've defined a storage account in the Azure portal, there are certainly ways that you can go and find any storage accounts that have got HTTP turned on and that shouldn't have. But wouldn't it be even cooler if you could move that process way earlier in your development cycle, where you can actually check all of your Bicep code or all of your infrastructure definitions to say, have I got any storage accounts that would be deployed with incorrect configuration, or configuration that somehow violates my customer's policies? So we can build a whole bunch of automation around, looking for errors, looking for security problems, looking for bad practices across all of our code.
And those are some things that wouldn't be caught necessarily from using other, and we're going to talk about this in a bit, but other tools like Azure Policy, which kind of puts those guardrails around your deployments. I mean, this is looking for some of those specific properties within some of the resources that we're deploying that would get caught in a scan.
Exactly. Yeah. And more importantly, it moves it earlier as well. So Azure Policy is really good if you want to find resources that you've already deployed that don't kind of match what you expect. You can also tell it to avoid deployment of resources too, but ideally you want that to happen really early in your development process before anybody gets too committed to this code.
Absolutely.
Cool. So another really big benefit of the confidence that you get from infrastructure as code is around how you manage secrets. So tell me if this sounds familiar. If you've worked with Azure before, you will probably have somebody somewhere has a Word document, hopefully, hopefully not a Word document, hopefully some sort of secure note that has a whole bunch of information like connection strings and passwords and certificates and all sorts of other things like that are kind of key parts of the configuration of your environment, but that are highly sensitive. Now, if you're doing everything manually through the portal, then you pretty much have to keep that somewhere and try and refer back to it and copy and paste values into configuration settings and those kinds of things. When you use infrastructure as code, you can integrate that really nicely with services like Azure Key Vault. So Key Vault is designed to store secrets and other secure data. And so you can put all of that data into Key Vault and then have your infrastructure as code tools refer to those secrets. So the people running the deployments never even see the secret values, right? They all they know is that there is a secret in there somewhere and it's got this name. I don't know what the value is. So in terms of making sure that your infrastructure team is running in a really secure manner, and that you're not accidentally leaking secrets anywhere that you didn't intend to, this is a really big benefit as well.
So you're saying don't put passwords and connection strings in templates and scripts? is what you're
Absolutely.
what
Yeah.
you're stating.
Yeah.
Okay. Okay.
Yeah.
Just making sure.
Yeah.
Making sure.
That's definitely a good practice. And in fact, we'll look at this a little bit more in future Learn Live sessions, but Bicep will actually even tell you if you're doing some things that look like they're possibly insecure.
Awesome.
So certain types of secrets, it'll actually watch out for those and tell you that you probably don't want to put those in your Bicep file.
Okay.
So the next benefit around confidence is access control. So when we deploy our Azure resources, we want to make sure that only certain people can make those configuration changes, and that there's a controlled process to do that. This might not be such a big issue with kind of sandbox environments or development environments when you're first getting started with a project, or when you're making changes and you want to just try things out. But certainly when we get to production environments, it's really, really important to have a good access control policy and process that you can enforce, to ensure that the right people are executing the deployments, and that they've been through all of the different controls or the different quality gates that you've defined. So one of the things that we actually really encourage customers to do is, once you've got infrastructure as code embedded in your organization, and once you really understand how to use it well, one of the things you can actually do is hopefully turn off all of the human access to certainly to your production environments, or just give humans read access and not write access. And the reason for that is that you can then ensure that any changes that are being made to your production environment have gone through the process that you've defined. So you're not going to accidentally have somebody come in and make a change that you didn't intend, or that has increased the attack surface of your solution or anything like that.
Yeah, on that, John, I think that in a lot of the customers that I talk to, that's a big culture shift in the way that their operations teams work.
Yeah.
A lot of infrastructure engineers are so used to, from an on-premises perspective, okay, I've got a problem with my server. I'm going to go log into that server. I'm going to fix that particular server. But we're seeing that a lot with our customers that have kind of hit that certain level in their culture where, nobody's going in, just like you mentioned, read access only, for regular user accounts. And then the accounts that are doing those actual deployments are going to be those managed identities or those service accounts.
Exactly. Yeah. But I also understand, and I think we've all seen the scenarios where, you have a middle of the night emergency wake up, that something happens that you absolutely have to make a production configuration change right now. So we don't want to completely limit the possibility of doing those kinds of things too. So one option for that is to create things called break glass accounts. So these are special user accounts that do have privileged access to your Azure environment. But in order to use those accounts, you have to kind of go through some hoops, right? You have to, pull a password out of a password manager and explain exactly why you've used it. Or you have to use a feature like Azure Active Directory's privileged identity management, which basically means that you can temporarily escalate or elevate your permissions to be able to do things that you wouldn't normally be able to do. So those are really important features to be able to give you some confidence that even if your infrastructure as code is kind of your primary way of deploying your infrastructure, if you have these kind of emergency situations, then you can go through a process to be able to make manual changes temporarily. But the goal should always be then to once you've resolved that emergency, once the fires stop burning, then you update your infrastructure as code to bring it back into line with whatever configuration change you just made.
Yep.
Cool. And then another benefit is around configuration drift. Now, Josh is going to talk about idempotence shortly. Basically, idempotence means that you can run the same operation over and over again, and it will have the same result, right? So if you say, for example, I want to have a storage account that's defined in this way, and you deploy the storage account, the next time you deploy the storage account with the same configuration, it's not being redeployed. It's not being deleted and recreated. What's actually happening is Azure is looking at the configuration and saying, this already exists. It exists in the configuration that you've asked for. I'm just not going to do anything, right? So when you use infrastructure as code, you can avoid configuration drift, which means that you've got two different configurations. You've got the one you've defined in your spec, and you've got what's actually deployed. You want to try and avoid that as much as possible. So by using infrastructure as code, you can ensure that your deployments are always going to be consistent, right? They're always going to follow the definition that you've specified in your infrastructure as code template.
Awesome. Yeah. So let's take a look at that real quick. So talk a little bit about creating something inside of Azure from the CLI. So I've got a command here on line 2. I'm going to create a resource group. So if you're not familiar with what a resource group is, we're going to talk about that a little bit later. So don't worry. But what I'm going to do here is I'm going to create a resource group. The name of that resource group is simply going to be storage-resource group. And I'm going to place this into the East US region, right? So I'm going to execute this command down here in the terminal. And you'll see a response that comes up here in a second. And that was a successful deployment. So what's happened there, again, I've created a resource group called Storage Resource Group in the East US region. And just to show you, let's see if it's shown up yet. It hasn't come up in my portal yet. I'm just doing a quick little refresh. Taking a little bit of time to show up in the portal. But the point of this conversation here, and I'll swing over to the portal here in a second, is that no matter how many times I run this particular command, as John mentioned before, Azure is taking a look at what already exists and what I'm telling Azure to do and says, hey, this already exists. So this is just going to be a successful redeployment. I'm not actually deleting the resource group. It is simply just checking the exact state and then responding in kind. So here in the...
Josh, does that mean that the second deployment is going to be much faster than the first as well?
It should be a little bit faster, right? Obviously, depending on how many resources are involved there. But yes, it is faster, right? So you can see here in the Azure portal, I've got storage-resource group that exists in the East US region. By rerunning this command over and over and over again, it's not creating additional resource groups. It's simply just verifying that particular piece exists, okay? All right, so let's move on to the next section in regards to benefits of infrastructure as code, right? So many organizations are maintaining multiple application environments. So this talks about the concept of provisioning new environments. And if you think back to our scenario, right? Our tour company is experiencing some significant growth. We've got to get new applications online, both for our customers and both for our staff. We've got to make these applications globally available. So we may be deploying new environments in other regions and other part of the world. And it's taking advantage of that main benefit of cloud computing, right? If you've sat through any presentation on cloud computing or any discussions on cloud computing, it's the ability to scale, right? The idea to be able to spin up additional environments as quickly as possible, right? So infrastructure and code gives us that capability to do that as fast as possible. When we talked about kind of like the human error component and the manual deployments, it's much easier to target a pipeline at a new region with some slightly different names to deploy a new version of that application somewhere else. So it gives us the ability to dynamically provision those environments, again, consistently, as John was talking about before. So,
and actually, Josh, just before we move off that point, one of the points that we had on that slide there was around environments that you don't necessarily want to keep running for a long period of time, right? So we've listed here penetration testing, load testing, even bug testing. Can you talk a little bit about why that might be a good idea to do through code?
Yeah, so let's say that your environment is running fully in production. It's time for your yearly penetration testing, or you want to do some load testing or some bug testing. You can spin up an identical environment, right, with just some slightly different names to resources. It can be in the same region. It can be in a different region, but spin up an identical configuration, including the data backend, right, so that you can run some tests against that to see if there's any security holes. And because those environments were provisioned exactly the same in a consistent manner, we can extrapolate that the security in this one particular environment should match the security in the other environment. Load testing and bug testing, if we're going to be introducing new features, right? And that kind of ties into the next section on non-production environments, right? But we want to test new features and we want to test bugs, that we could simply spin up one of those environments, do our test, and then tear that environment down, right? Because when that environment's torn down, we're no longer paying for those consumption costs. We're no longer paying for those VMs or those app service plans or AKS clusters when those things are running, right? So many organizations, John, I'm sure a lot of your customers that you work with, I know the customers that I work with on a regular basis, they've got a production environment. Maybe they've got a dev environment, a test environment, UAT, QA environment, right? They're going to be doing different stages of their application deployment to those different environments and doing all of those tests before they eventually promote those to production, right? One of the other things that I see frequently from my work and my customers is that I'm in the ISV space. I'm in the independent software vendor space. SaaS organizations, software as a service organizations. And a lot of those organizations are spinning up environments kind of on a per customer basis, right? They're providing a solution for those customers. So they want to spin up an identical configuration, or they can even have some slight modifications using some like conditional based deployments, which will be another conversation later on in the series, right? But the idea is they onboard a new customer, run this pipeline, build this new environment for this new customer, and they're ready to go, right? So that's another feature there around that non-production environments.
So Josh, make sure to understand that. So let's say that I'm a software vendor who's building some software for legal firms, say some document management software.
Sure.
So you're saying one of the options that I've got when I use infrastructure as code is I could actually deploy completely separate copies of my solution for each customer that I've got, but then also configure them maybe slightly differently if I need to by using some of those features you mentioned.
Yeah, absolutely. Right? Yeah, like so say for example that you've kind of got a bronze, silver, and gold version of your application, right? 3 different tiers of your application in your design that are tailored for certain size organizations, right? Maybe they're processing a whole bunch more transactions, customer A is than customer B. So you want to provide that different level. So with infrastructure as code and parameters and variables and conditional deployments, which again, we're going to talk about in a future episode, you could make a statement inside the template that says, hey, this is bronze. And if this is a bronze deployment, configure this many VMs with this many database servers with this size app service plan versus gold, which may include, additional compute power or additional storage power. Absolutely.
Awesome.
Yeah.
Awesome.
So the other one on here, disaster recovery. This is one that actually I've seen come up a little bit more. For customers that are, building an environment in a primary Azure region, they're focusing very heavily on increasing the high availability within that region. But many organizations obviously have to plan for significant disaster events. Now, there's multiple ways that you can configure disaster recovery, right? We can use things like Azure Site Recovery to replicate VMs from one location to another. But infrastructure as code can be used as a part of that disaster recovery plan. Again, thinking back to our scenario of having to stand up new environments for our new customers and partners around the world, organizations can use that in the same way for disaster recovery. We've got our primary region, but there might be an extended outage of a particular service. So the team may make a decision, you know what? We're going to redeploy this completely over to West US as opposed to East US. And again, if we're doing this with infrastructure as code, our templates are set, our configuration is set. We may just make a slight name change in one of the parameters, and it'll completely rebuild that environment in a different location.
Awesome.
All right. The next feature or benefit, I should say, of better understanding your cloud resources, audit trail, right? So the same way that software developers are checking in code using Git repos and things like that, if you're handling your infrastructure as code the same way, that same type of audit history is going to be there. Who made the change? When was the change made? What was the change? Now you have to go ask the person why they made the change, right? It doesn't include why, right? But it does discuss the who, what, where, and when. Documentation, right? There are a lot of features within infrastructure as code that give us the ability to add things like metadata and comments, which can help us describe the purpose of what's being deployed in those particular templates. The same way we see, comments available in regular application code, those features are available within templates, whether you're using ARM templates, Bicep templates, or other third-party templates that are out there. So if you have a documentation process within your organization that your developers are already following, bring that same process to your infrastructure as code. All right. Unified system. This really kind of adds to what we were just talking about there. And then also this was mentioned a little bit before. But in the core definition of infrastructure as code is that we're treating our infrastructure code the same way that we are our application code. Many organizations already have those processes and procedures in place, but now we can use that same system for both the operations team and the dev team, which is leading to, right, obviously the term DevOps, right? So this brings those two worlds together in using the same tools, right? All right. So the last one here, better understanding of your cloud infrastructure. And John kind of touched on this a little bit before, but this is very, from personal experience, this one is huge to me. Years ago, when I got into working with Azure, and then shortly after started working on ARM templates, I found that I learned more about how a resource functions by trying to write a template for that resource than I did going into the portal and deploying it, right? So because when you build a template, it's going to tell you exactly what properties are required, what features are required, what things need to be there. And it helps you get a better understanding of what it is that you're actually configuring. I'm an infrastructure person, right? But the first time I went to go build an event hub or I went to go build an app service, I didn't know what all these properties and values were. So it really helps you get a better understanding of your overall cloud resources. One other point here is that sometimes when you deploy something in the portal, not all of the components that actually get deployed are part of that screen inside the portal. So for example, when you build a virtual machine, there's a disk that gets created in the background. Your only options of configuring that disk in the portal is to state what type of disk it is. Is it a premium SSD? Is it a standard HDD? You don't have any choice over the name of the disk or the configuration of the disk. But if you're specifying a template for a VM, you get that level of control. The network interface is not something that you configure at the deployment time of a virtual machine. But again, with infrastructure as code, you have the ability to name that NIC and do those additional properties there. Okay. All right. So we kind of teased this a little bit before. We were going to talk a little bit about imperative versus declarative code. So John, tell us a little bit about the difference.
Yeah. So basically, imperative code is where you specify a sequence of commands, right? So you specify all of the details of exactly what should run and when. So for example, if you've ever written things like Azure PowerShell code or just PowerShell code overall, or Bash scripts or anything like that, you're providing a sequence of instructions. You can include things like loops, like conditions to say, if this happens, then do this multiple times, et cetera, et cetera. But you're providing a kind of a step-by-step list of instructions. So if you think about our toy company analogy, well, our toy company builds toys and they provide these manuals. Some manuals might include step-by-step instructions for how to configure your toy or how to assemble your toy, right? So imperative infrastructure as code essentially is the same kind of idea. You're providing a sequence of instructions, and that means that you have to account for things like, if something doesn't quite work the way that you expected, or if it didn't return the result you expected, what should you do then, right? So you get a lot of control over exactly how things work, but with that control comes some responsibility. The other form of infrastructure as code is declarative code. This sometimes is called desired state configuration as well. And it basically means that you provide a definition of how you want your environment to look. So you're saying, I expect that at the end of this deployment, a resource group will contain these resources here. You don't care how that's deployed. You don't care what sequence it's deployed in. You don't care, what's going on behind the scenes to make that work. So again, if you think about a toy manual, some toy manuals don't give you step-by-step instructions. Instead, they just kind of show you a picture of a toy with all of the pieces of it in the relevant places. And it's up to you to figure out how you get them there. It's the same kind of idea here as well.
So John, is there really kind of an advantage of one method versus another, or perhaps disadvantages between the two methods?
Yeah, I mean, the big disadvantage of imperative code in my mind is that you do need to allow for all those different possibilities and deal with all of the possible, different return codes you get from different operations or unusual errors or those kinds of things. Obviously, and when you work with declarative code, you can still get errors, but because you're not having to worry about the sequencing, it's possible that you can still have most of your resources deployed, even if one of them fails. And then behind the scenes, the system that's executing your deployments, which we'll talk about shortly, Azure Resource Manager, might actually be able to retry that silently for you and then create the resource without you even noticing that something went wrong.
Okay. I think complexity could be a potential issue as well, right?
Yeah, absolutely.
Managing a really long script, right? That's hundreds and hundreds and hundreds of lines of code to do all those pieces individually. Not to say that a template, a declarative template,
can get complicated
incredibly
as well.
complicated as well. But we'll actually talk about some ways a little bit later on how we can kind of make that a little bit easier to author and look at. So
that's right. Yeah.
All right. So go ahead.
Yeah, so I was just going to say, so if you're used to things like Bash or Azure PowerShell or any other scripting language, then you have probably written imperative code before. So Josh, I think you're going to have a look at some examples of some imperative code, right?
Yeah. We're just going to build a little bit on what we had done before, right? In the first example, we talked about an idempotent operation where we created a resource group called Storage Resource Group in the East US region. So what we're going to do here is we're going to rerun that command again, because again, it's an idempotent command, but here we're going to actually go create a storage account in that particular resource group. So first, I'm going to go ahead and execute my command here. I'm going to go ahead and it's going to validate that that resource group already exists. So I should get a response here in just a second that everything's fine. Did I not press there? It's taking a second to go. So while that's going, oh, there it is. All right. So the next command here in line 4, what we're going to do is we're going to build a storage account. So we're going to use the AZ CLI command, AZ storage account create. We're going to give this storage account a name. That name is going to be storage learn live. We're going to put it in the resource group that we specified on line 2. And then we're going to configure some of the properties for this particular resource, this storage account. We're going to specify that it is a standard LRS storage account. LRS stands for locally redundant storage. Not getting into storage account configuration today, but that's what standard LRS is. The type or the kind of storage account it is a storage V2. We're going to put this in terms of the data that goes into the storage account. We're going to put it on the hot access tier. And as John kind of hinted at before, we're going to make sure that we enable HTTPS only for this particular storage account. So John was referencing code scanning earlier, which might be able to take a look at some of our infrastructure as code. And if this was set to false, right, this could generate an error in the code scan. So we're going to go ahead and set this to true. And we're going to go ahead and save this file. And I'm going to go ahead and run line 4 in my terminal. So this is an imperative approach, right? This approach is I've got to create the resource group first, and then I have to create the storage account after that. Well, maybe there were other parts to this solution. Maybe there's a virtual network. Maybe there's a virtual machine. And those things would have to be put in sequential order, and we would have to determine the appropriate order for that full deployment to work, right? So we see here that the storage account has been built. Hopefully we'll see that refreshed here in the portal in a second, and I'll show you there. Sometimes you get a quicker response in the CLI than you do actually inside the portal. So sometimes we have to wait a little bit there.
Yet another benefit of infrastructure as code, right?
Yes, exactly. All right. It hasn't shown up yet, but it will show up here actually in just a second. But for the sake of time, I'm going to go ahead and move on in the presentation. All right. So declarative code. John, talk to us a little bit about declarative code.
Yeah, so we kind of touched on this before, right? So instead of specifying the step-by-step instructions that you want to follow, with declarative code, you specify what you want to have happen at the end of the process, right? You don't care how it happens, you just want this configuration to exist. So there's, and we call those files templates. So there's a few different ways that you can go about doing infrastructure as code by using declarative code. So one option is to use a JSON-based language. So if you've ever worked with ARM templates before, Azure Resource Manager templates, these were all based in JSON. Josh will actually show some examples of the JSON syntax a bit later. I'll quickly put in a spoiler here and say we don't recommend that you use those. those were the only option for a long time, and behind the scenes they're still used today. But you shouldn't ever need to write another JSON template again, in my opinion. So instead, you write code in a language called Bicep, which of course is the topic of this Learn Live series. But Bicep isn't the only declarative code approach that you can use. We're not going to go into these in detail, obviously, but you feel free to research in your own time if you're interested. There's also other tools like Ansible and Terraform. And these tools, you've probably heard of some of these before, and there's plenty of others, I should say, as well. These are all declarative approaches as well. They all use slightly different languages and slightly different approaches, but fundamentally, you provide the state of your resources at the end of the deployment, and the system takes care of figuring out how to make that happen.
Great. So yeah, let's take a look at a Bicep template. So this is the first time that we're actually looking at a Bicep file and what the structure of that particular file is. Now, I'm not going to go too deep into all of the pieces around this, but what I do want to point out is that this particular file that we see here is the exact same thing that we see here in line 4 of this AZ CLI command. I am defining a storage account. I am calling that storage account storage learn live. I am making that a standard LRS storage account. It is a storage V2 version of the storage account. Its access tier is hot. And again, it supports HTTPS traffic only. So this Bicep file is the exact same configuration as the storage account that we built on the AZ CLI command. So in order to deploy this particular file, we'll just do a quick little deployment. So I'm going to do an AZ deployment group create, right? I'm going to specify the name of the resource group that we're going to deploy to, which this is storage resource -group. And then I'm going to point to the actual Bicep file that we're going to deploy. So in this case, I'm going to do 3_declarative.bicep. And I'm going to go ahead and submit that file to Azure Resource Manager. So the same way that we looked at idempotent commands from an AZ CLI, this is essentially the same thing, right? Azure Resource Manager is going to check the current state of that particular resource, determine whether or not it exists, look at what we're submitting, and if there are any changes to be made, it'll make those changes. But since it's identical, no changes are actually going to be made. All right. Oops. Okay. So let's talk a little bit about Azure Resource Manager. All right. So jumping back into our scenario. So our team here at the toy company, we've learned about the benefits of infrastructure as code. We've learned about the differences between imperative and declarative approaches to infrastructure as code. And then we decided that we're going to go with a declarative approach, right? We decided that we're going to go with templates because our team doesn't want to maintain scripts. We don't want to follow that imperative approach. But before we start building that first template, we need to have a conversation around what is Azure Resource Manager. So John, talk a little bit about what Azure Resource Manager is.
Absolutely. Azure Resource Manager is the part of Azure, the service that's used to deploy and manage resources in Azure. So when you work with the Azure portal or other tools, behind the scenes, Azure Resource Manager is the thing that's being used to actually deploy, configure, delete all of your resources. Now, importantly, regardless of which tool you're using, like I said, the portal or something else, you are still working with Azure Resource Manager behind the scenes. So Azure Resource Manager is essentially the kind of the APIs and a bunch of the kind of the back-end systems that all of those different tools like the portal, PowerShell, CLI, and also Bicep all sit behind, right? But also Azure Resource Manager does more than just the deployment process as well. So it also handles things like access control. So who actually has access to your Azure resources and what can they do with them? Auditing. So keeping track of what changes were made to resources and logging those somewhere that you can review later. Tagging. So that's where you can provide additional metadata about your resources. And you can then, query for resources that have particular tags on them as well. So all of those features are all kind of resource management features, which is why they sit under the Azure Resource Manager service. So it's really worth understanding really, really well how all of these services, how all of these tools that you use flow through to Azure Resource Manager. As you can see here, Azure Resource Manager sits in the middle of a lot of different processes. So regardless of whether you're working on the portal or whether you're working on in the CLI or Bicep or something else, behind the scenes, everything you're doing is being translated into requests to Azure Resource Manager. And then behind the scenes, Azure Resource Manager then sends those requests or sends further instructions on to the services that actually run the different parts of Azure. So databases and web apps and virtual machines and so forth. So Azure Resource Manager kind of acts in the coordinator role, right? You provide a set of instructions. Azure Resource Manager then sends those instructions to different parts of the Azure system.
Yeah, I really like to point out on this particular piece, John, I know you kind of said it, but I really want to reinforce this, is that it really doesn't matter what tool, right? It doesn't matter if your team deploys through the portal. Obviously, we're talking about infrastructure as code, but it doesn't matter if your team deploys through the portal or that uses Azure PowerShell, CLI, templates, other tools like Pulumi or Terraform, or directly from Visual Studio. It doesn't matter which tool that you use. You're still interacting with Azure Resource Manager, and use the tool set that your team's comfortable with using.
Absolutely. Yep. So so as we start to learn about Azure Resource Manager and start working with Azure, there's some terms and concepts that we need to really understand well to be able to be successful. So let's have a look at that three kind of key terms, and then we'll expand that list out a little bit further as well. So the first thing is a resource. So when we think about things like a storage account or a database or a web app, these are all individual manageable items that are made available by the Azure platform. And so each of these are resources, right? We consider these to be things called resources. And a lot of diagrams, you'll see these represented as cubes, which is a nice kind of visualization of these. You have lots of these different resources all put together. Now, resources are combined or contained in a resource group. And a resource group is just a logical container. If you're new to Azure, resource groups have very little to do with things like networking or identity management, those kinds of things. It's kind of just a logical container for your resources. And you can decide what resources to put into which resource group based on what makes sense for your solution. So, for example, in the toy company, you'll be seeing lots of different examples over the next few weeks around different parts of their systems that they work with. And so, for example, their HR system might be deployed into one resource group. Then their financial systems might be deployed into another. The website that they're using to promote their toy products might be deployed into a different resource group. So you can kind of decide how you define those resource groups based on your requirements.
Yeah, that's a big conversation that I have a lot with my customers when they're first getting into Azure. How are we supposed to organize things? And I always kind of respond, it's like, hey, we've got some best practices, but like you said, it's really up to you. There's technically, only one really wrong way would be putting everything into one resource group. Yeah. But I think it's a really important thing to kind of get right. I think the main piece of guidance that we offer is if resources share a similar life cycle, right? Then that's a good argument for putting them in the same resource group. For example, like your networking resources, right? Those are most likely going to persist, past the lifetime of some of your VMs, or perhaps past the lifetime of some of your app services if they're integrated with private endpoints or something along those lines. So you may want to put your networking resources in your own resource group. But as John mentioned, it's really just on what makes sense for your solution and what your organization's process is.
Absolutely. Yeah. And then resource groups are contained in things called subscriptions. So subscriptions are essentially kind of another layer of container, but they also act as a billing boundary for your resources and your resource groups. So you can have multiple subscriptions, and in many organizations, they have many, many different Azure subscriptions. But you might have different cost centers or different information about the resources that are tracked at the subscription level. Now, once we've got got that kind of basic hierarchy, we can actually extend that with another thing called a management group, or a set of management groups, and these can actually be used to contain subscriptions. So you can define a hierarchy of management groups, and you can actually have multiple management groups in different layers that represent, for example, different parts of your organization's hierarchy, or different ways that you manage your Azure resources. We're not going to get into detail on management groups today. We do actually talk about them in some later Learn Live sessions. But basically, especially if you're working in a larger organization, you might want to use management groups to be able to kind of put some governance and management around your Azure environment. Now, what we do want to talk about today, though, is the templates, right? So we're going to talk about Bicep, but before we get to Bicep, it's worth talking about Azure Resource Manager templates. I touched on these briefly before. These are the files that define the resources that you're going to deploy. Typically, these are deployed to a resource group. So a storage account is deployed to a resource group. But you can actually deploy all sorts of other resources to all different parts of Azure. And those templates are those declarative templates that define all of your resources in a consistent and repeatable way.
All right, so let's kind of dive into ARM templates a little bit more. And again, we're really just kind of focused on those JSON ARM templates, what's really defined in Azure. And then we're going to step into Bicep after having this particular conversation, right? So again, an ARM template is a declarative approach, right? We have decided that we're going to go down that particular path, and our ARM template is going to define all the individual pieces of that application. It may include an app service plan, an app service, a SQL database, right? And when we submit this template to Azure Resource Manager, we kind of talked about that a little bit before, both from the imperative and declarative side. Azure takes a look at what you're submitting in that particular template. If there is an existing version, like if this is a redeploy, it compares it against what already exists, and it'll do that deployment into your environment. The one statement the one piece I really want to focus on here on this particular slide is the organized manner, right? When we talked about imperative code, we had to determine the appropriate sequence of events for something to be built within that particular script. With ARM templates, we have a way of, in the older method, we did have to spend some time determining those dependencies inside of the template. But as you'll see throughout this series, Bicep provides a way to kind of automatically create those dependencies. So when the template gets submitted to Azure Resource Manager, by default, it wants to do these deployments in parallel, But if dependencies are defined or automatically calculated, Azure Resource Manager says, well, I can't deploy the app service plan until I've deployed, can't deploy the app service until I've deployed the app service plan. So that organized statement right there is a huge part and a huge feature there, right? So a couple of the other benefits of ARM templates, and we've kind of covered the concept of repeatable results, right? These are idempotent operations, meaning you can repeatedly deploy the same template. Another question that we get very frequently from our customers here is, and we've kind of addressed this, is, well, if I redeploy, is it actually destroying my resources and then recreating? The answer to that is no, right? The default method of deploying resources inside of Azure is what's called an incremental mode. Again, Azure takes a look at what you have and it compares it to what you're submitting and will only make those changes. And that works 99, John's going to start smiling about this, but 99.9% of the time, that is the case. There are a couple of resources where idempotent operations don't function completely. So again, from an orchestration perspective, and we kind of touched on this in the dependencies section, resources will be deployed in parallel unless those dependencies are specified or those dependencies are automatically calculated. The difference between old JSON templates and new Bicep templates, a huge benefit to customers that might be used to writing those ARM templates is that automatic dependency calculation. And we're going to be talking about that throughout this particular series. Preview features. We have the ability with the what if tool, which is a tool that's available in both Azure PowerShell and Azure CLI, which will actually kind of give us a report, a preview of what's going to happen if we do submit that particular template to Resource Manager. It details any changes, whether they're creations or modifications or deletions, and it'll show that to you in a report. Testing and validation. So some of the things that are available to us with ARM templates, we can use the Bicep linter inside of VS Code that can give us some ideas of some things that we may need to change or some values that are missing, some names that are incorrect. There's also a template validation process that occurs. If you've ever built anything inside the Azure portal and you get to that review and create page and you hit that review and create button and you see that there's a template validation that's happening at the top of the screen, this is happening before the submission actually happens. It's looking at your template, looking at your configuration, and verifying that it is ready to be submitted to Azure Resource Manager. Modularity. We talked a little bit before about how sometimes scripts or even templates can get very long, like hundreds and hundreds of lines. We have the ability to break our templates up into smaller components called modules and then link them to a larger template at the time of deployment or a main template at the time of deployment. There are going to be multiple conversations around modules in the weeks to come. As John mentioned very early on in a graphic, that we can integrate these templates with our CI/CD processes, whether we're using Azure DevOps or GitHub Actions. Both ARM templates, Bicep templates are supported within those particular tools. Extensibility. Now, this one is we have the ability to utilize deployment scripts within our ARM templates. And deployment scripts, we can actually do some imperative code inside our declarative templates, right? So for example, we can have our ARM templates interface with Azure Active Directory, which is a completely separate structure than Azure itself. So we can still execute some Bash and PowerShell at certain times, but there are some things coming around extensibility and Bicep in the future that might make that even easier to work with, but we're not ready to talk about that just yet. Okay. So we're going to talk about two types of ARM templates. We're going to talk about JSON templates and Bicep templates. So as John mentioned in a previous slide, JavaScript object notation is that standard open file format that multiple languages take advantage of. Bicep is our new domain-specific language that was developed specifically to make the process of writing, so authoring templates and reading templates easier. And we're going to do a little side-by-side comparison in a bit, and you're going to see what kind of difference that makes. But again, you can use either of these formats for your ARM templates and resource deployments. It doesn't matter. You can submit a Bicep template for deployment. You can submit an ARM JSON template for deployment. So let's go ahead and talk a little bit about Bicep. So back to our scenario. We have decided that we are going the declarative route, and we've decided that we are going to use ARM templates for resource provisioning. But now we want to take a look at those two different types of templates. We want to take a look at both JSON and Bicep.
Alrighty.
Yeah.
So Bicep is, as we've talked about, is a language that you can use to declare your resources in a declarative sense. It's what we call a domain-specific language, or a DSL. You don't need to worry too much about this, but basically a domain-specific language is a language that's been designed for a very specific purpose. What that means is that Bicep isn't supposed to be a general programming language that you can use to do anything. It's not there as a standard programming language that you can write any old piece of code in. This is specific to Azure deployments. Now, the intention here is, and Josh, if you can move the slide, the intention is, that's all right, is to make it easy and straightforward to understand and to learn and to write your code and write your Azure infrastructure definitions. And you can do this regardless of how much experience you might have already had with any other programming languages. So if you've never used a programming language before, that's completely fine. If you're an expert developer and you've written a lot of code before, it'll be familiar in the sense that you're writing structured code that defines your resources. But of course, the language syntax will be a bit different to what you've used before. And importantly, all of the different resource types and API versions and properties of all of your Azure resources are all valid in Bicep. So it's not like Bicep is a subset of the functionality of Azure. Bicep actually exposes everything that's inside Azure. So Bicep gives you some really good benefits, especially if you've already worked with the JSON language, the ARM template language. So the big one, of course, is the syntax. Bicep is a really, really nice, easy to read, easy to write syntax that you can use to write your templates. We'll actually be covering this in a lot of detail in both next week and then also in future sessions. So we're not going to get super detailed into the specific syntax of Bicep today. But suffice to say, there are a whole lot of really, really nice little features in Bicep that just make the experience of writing your Bicep code so much more pleasurable than JSON. And then, of course, Josh mentioned modules. So technically, you've been able to do things like modules and modularization in JSON templates. It's always been a little bit tricky to do that really well. Bicep gives you a really, really nice experience to do that. Josh hinted at the fact that we've got automatic dependency management and dependency tracking. So this is a really big benefit when you've got complex deployments or complex templates. You don't have to remember that this thing needs to defend on this thing, which means that the sequencing needs to be done in a particular way. Bicep figures that out for you most of the time. And also the tooling, the experience that you get when you're actually writing Bicep code is really nice as well. So there's a Bicep extension for Visual Studio Code, which Josh will be showing you soon. And that provides a whole bunch of rich validation of your code, IntelliSense to help you write it, and also information about all of the different Azure resource types that you're going to be working with. So that provides a really, really nice experience to write your Bicep code. So Josh, do you want to show us what some Bicep code looks like?
Yeah, let's take a look. All right. So this particular file, it's a just slightly expanded version of what we built before. If you remember, what we built before was kind of here in lines 7 through 18. But we've added some additional features or additional lines of code in this particular file. We've added a series of parameters and added a series of variables. So parameters and variables, and there's another session that's going to be done exclusively on parameters and variables and how to use them. But parameters and variables allow us to inject values into certain properties that kind of exist down here between lines 7 and 18. So for example, there's a parameter here called location, right? And if you take a look there, that location is equal to this resource group.location function. Meaning when I run that AZ group deployment command, it is going to deploy this particular resource to the same location as that particular resource group. In this case, East US, wherever that particular piece landed. If you notice, I'm referencing the parameter down here in line 9. So I have a property called location, and I'm stating that parameter is the value of location. So if I were to actually take this away, right, and put in East US, you see, I get a couple of errors inside the VS Code IntelliSense, right? One is it's telling me here that I'm not referencing this parameter anywhere in the file, right? I've defined a parameter, but I'm not using it. Down here, this is giving me an error that said you should actually not use specific resource locations as hard-coded strings, right? So it's actually kind of giving me some hints on what I should be doing to kind of fix that. So here I'm going to kind of replace that. And if you notice that my errors went away. Other thing that I want to kind of show you here, from a benefits of Bicep here is the string interpolation, the ability to kind of create unique names or create naming conventions with our parameters and variables. So if you take a look here, I've built a parameter called name prefix, and I've given that name prefix a value of storage. And then I'm creating a variable, and we'll talk later about the differences between parameters and variables. But I've created a variable here called storage account name, which you can see that I'm defining as the property of name on line 8. But what I'm doing is I'm actually concatenating or doing string interpolation, if you will, to create this full name. I'm starting with the prefix, which is defined above as a parameter. And then I'm actually running a really cool function here called unique string. Actually, I just made a quick little error there. So what I'm doing here is I'm running a function called unique string, which is going to append a suffix to the name of this storage account based on some unique numbers of the ID of the resource group. So when this storage account gets built inside of Azure, the name of the storage account is going to be what this variable is. And in this case, it's going to be storage and then some unique sequence of numbers, right, to identify that particular storage account name. The other thing that's on here that we hadn't talked about before is this line 20. This is an output. This output is going to give us the resource ID of that storage account. So if we're thinking about some of those modular deployments that we talked about before, right, those modular deployments, we can output this value from this particular storage account and then use that as an input on another module later on. And if we do that, that's where that automatic dependency calculation comes into play, right? Bicep or Azure Resource Manager knows that if there's a resource further on down that is going to use the resource ID of that storage account, then the storage account has to be built first, okay? All right. You were going to spend a lot of time over the course of the next few weeks taking a look at Bicep files, but that's just kind of an introduction there, okay? All right. So let's talk a little bit about how Bicep works. So again, sticking with our scenario, right? We've got an understanding of the Bicep language and the benefits that it provides to template authoring. And we're going to go ahead and make the decision. We're going to go down the path of using Bicep for our infrastructure as code. So John, talk a little bit about how Bicep actually works and what is happening kind of under the hood.
Yeah. So if we look at this diagram on the slide, I think this does a really good job of showing us the kind of the overall flow. So firstly, you as the template author, the person who's writing the Bicep code, will use things like the Visual Studio Code tools that Josh has just showed, and you'll end up writing this Bicep file, right? Or actually, might be multiple files as well. Once you've got that Bicep file, what's actually happening is when you deploy that to Azure, behind the scenes, there's a process called transpilation that converts your Bicep template into JSON. So natively, Azure kind of speaks the JSON language, right? It doesn't actually really understand the Bicep syntax. So the Bicep tooling that you use will actually convert your Bicep file into a JSON file. And again, that process is called transpilation. So it's translating essentially the Bicep language into JSON. When you've got a very simple Bicep file, that actually looks kind of similar, right? There's a few differences in terms of the syntax and the quotes that are used and those kinds of things, but it looks pretty similar. When you get to complex deployments though, and you've got lots of different resources, you will notice a big difference between the JSON and the Bicep versions of your code. The Bicep file hopefully is very easy to read and very clear and very well structured. The JSON file, the more complex you get, the more the JSON file looks like a big mess, frankly. So it's something that we don't necessarily suggest that you need to go and look at yourself. And actually all the tooling kind of takes care of all of this for you behind the scenes. So you submit a Bicep file to deploy to Azure, and behind the scenes, that's then converted for you. Or you can do it manually if you really want to.
All right. So actually, let's do a quick comparison on that. So as John mentioned in the previous section right there, is that when we do submit that Bicep file to Azure Resource Manager, the tooling actually does that automatic conversion of that Bicep file into a JSON template and submits that to Azure Resource Manager, right? That's transpilation process. But we do have the ability to actually perform that task manually, right? So let me go ahead and pull my terminal back up. And I'm going to run a command here called az-bicep build, right? And I'm going to do the actual Bicep file. We're going to point to this 5_build.bicep. So this file that we see up here above, this is very similar to the storage account JSON storage account files that we've looked at throughout the episode here today. But what this command is going to do is it's going to go ahead and do that transpilation. It's going to convert that bicep file into JSON. So when I run this command over on the left-hand side, you should see a JSON file show up here in a second. There it is. So now we've got this build.json file. I'm going to go ahead and open that to the side. Let me turn off this and let me turn off this. So on the left is our bicep file with a couple of parameters and a resource defining the storage account. On the right would be the actual bicep file. I'm sorry, the actual JSON file that gets submitted to Azure Resource Manager. So taking a look at the difference, we talked about how this is an easier authoring process, an easier reading process for your templates. Take a look at the one parameter for location, right? This is actually really just one line because we're zoomed in pretty significantly here, but it's one line of code versus all of that, versus 5 lines to identify that particular location parameter. Same thing here on line 2, right? The difference between 4 lines of code versus 1 line of code. And this, as John mentioned, the larger files that you have, this really makes a huge difference between the readability and the authoring capability between these 2 files. Okay. All right. Let's see. Okay. So let's talk a little bit, John, about, actually forgot to mention this. There is a tool called the Bicep Playground. We can put a link to that in the chat, but the Bicep Playground is a website that actually will show you that conversion between JSON and Bicep. All right, so let's talk about when to use Bicep. So we've made the decision that we've gone with a declarative approach. We've learned about Azure Resource Manager. We've learned about our templates. We've learned about Bicep templates. But now we want to talk about the reasons to choose Bicep kind of as the main tool set for infrastructure as code. So John, when is Bicep the right tool? And let's talk about that.
Yeah, so Bicep has some really big advantages. So firstly, I'll just put a very basic statement out there, which is if you are considering writing a JSON template and you haven't already got one you're trying to reuse, but you're creating one from scratch, I would suggest you stop and use Bicep instead. That's a good rule of thumb. But if you're thinking about Bicep versus other tools, then there are some advantages of Bicep that's worth thinking about. So first one is that Bicep is Azure native. It's been designed by the Azure team specifically for deploying resources onto Azure. So what also happens is every time new Azure resources are released or when they're updated, Bicep will support those features immediately, right? So we don't have to have a kind of a process by which we expose those new features or those new resources to Bicep. It just happens automatically. That's in comparison to some other tools where they have a little kind of abstraction layer sitting in between their tool and Azure, which means that every time something changes inside Azure, they need to update that layer. We don't have to do that with Bicep. But also because it's an Azure native tool, it's integrated really nicely with the Azure platform. So you'll see some of this in the next few weeks, but you can do things like monitor your deployments, your Bicep deployments through the Azure portal. And view deployment histories and all sorts of other information as well. Bicep is also a fully supported Microsoft product. So if you have a problem with Bicep and you've got a support agreement with Microsoft, you can contact the support engineer and they'll be able to help you to try and understand what's going wrong. Now, Josh, are you still there?
Yeah, I'm here.
Cool. All right. My screen is frozen, but that's all right. No worries. Now, another really big advantage of Bicep is the fact that you don't have state management. So Bicep deployments actually will compare the current state of your Azure resources with the state you define in the template, as we've talked about. This means that you don't have to maintain any kind of state information anywhere else. So, for example, have a storage account that you keep a state file or something like that. So some of the other infrastructure as code products do require that you do that, but Bicep actually will maintain all of its state inside Azure itself. And of course, as we've just talked about, if you're using JSON already, if you're using these ARM templates already, it's a very straightforward process to transition to Bicep because you basically take all the same knowledge you've got, but then we provide a much nicer experience to write the same kind of code.
I think we're actually going to have a full conversation in a few weeks on that migration process from JSON over to Bicep.
Absolutely, yep, and that's a really interesting discussion to have as well.
So what about when is it not the right tool? When should we not essentially consider Bicep?
Yeah. So, I mean, a good scenario when you don't want to consider Bicep is if you've already got a tool that you're being used in your organization. So if your organization is already settled on Terraform, for example, and they're using that across all of their deployments, then introducing Bicep might just add extra complexity because you've already got those investments that your organization's already made. And we're also, working hard on making sure that other infrastructure as code tools work really nicely on Azure as well. So there's no mandate to use Bicep. We're not going to be preferring that. But if you've already got that existing tool set, then it's a really good idea to keep using that.
Yeah, I think that's a really good point, John. I think the idea is that there's a suite of tools available for you to pick, right? You can go with templates, you can go with command line, you can go with ARM and your JSON and Bicep, you can go with Terraform. The idea is that we just want the experience to be good, right? Regardless of the tool that it is that you're going to use, we want that experience to go well, right?
Absolutely, yeah. And then the other reason that you might not want to use Bicep is if you're going to be deploying across multiple clouds, so multiple cloud vendors. So other cloud providers, of course, don't use Bicep. They might have their own languages, or you might be better off using a tool like Terraform. But of course, Bicep isn't going to be able to deploy to other clouds. So if you need to deploy to other clouds and you want to use a consistent tool across all of those clouds, then of course Bicep isn't going to work well for that scenario. But I think for any kind of Azure native deployment where you're predominantly using Azure, you're new to infrastructure as code, or you're adopting it really, really well, Bicep is a perfect choice.
Awesome. All right. Well, that is the end of the information today. We're going to jump over to a quick little knowledge check that kind of tests your knowledge of what you learned about today. So you should be seeing something pop up here. All right. Okay. So we're going to move down to the first question. And if you'd like to vote on this particular question, you can scan the QR code, or you can drop down to https aka.ms/polls. So the first question is: suppose you're deciding on a method to use to deploy your Azure infrastructure. Which of the following characteristics is a benefit of using of using infrastructure as code? A, infrastructure as code improves the consistency of your deployments. B, infrastructure as code requires that you deploy only a single environment. Or C, with infrastructure as code, you manually execute your deployments. So go to that particular poll and drop your answer on the question.
Cool. Do you know the answer to this one, Josh?
I think I do.
Yeah.
Yeah, I have a pretty good idea.
Okay.
We got a few votes
make a bet
coming
on this
in.
one?
What's that?
Should we make a bet? Should we take a wager?
Yeah, sure. Why not? I don't know. All right. Got a couple of answers popping up. They seem to be disappearing, actually. Saw some answers come in, and then it went back to no answers.
Yeah. People are still deciding, are they?
I don't know if they're changing their answers or we're just not seeing something here. Let me refresh the page and take a look. No. Okay. So I'm not seeing the actual vote numbers. So we've got a little technical problem on the back in the background there. So let's go ahead and take a look at the answer to question one. All right. Infrastructure as code improves the consistency of deployments. A. Absolutely. Oh, we had 18 votes. Okay. It finally showed up for me.
Wow.
So John, why is question B not correct, John?
Well, infrastructure as code does not require that you only deploy a single environment. So if you're working with multiple environments, then infrastructure as code is an awesome thing to do because you can use those same assets, those same templates across all of the environments that you're deploying. Awesome. So actually, when you're using multiple environments, it's even better to use infrastructure as code.
All right, and then C, we don't manually execute your deployments. That would be a portal-based deployment. So we're looking at automated deployments. All right. So let's go to question two. So suppose you decided to use infrastructure as code for resource provisioning. You're deciding between using an imperative or declarative approach. Which statement best describes declarative code? With declarative code, you execute a sequence of commands in a specific order to reach an end configuration. This process defines what the code should accomplish, and it defines how to accomplish the task. B, with declarative code, objects and classes are used to determine the final configuration of a resource. And C, with declarative code, you specify only the end configuration. You don't define how to accomplish the task. All right.
Oh, this is a tricky one. I think you need to remember back to the discussion about imperative versus declarative code and see if which one is which.
All right, we're seeing some votes come in. All right. How are we doing on votes? Producer, we have a good number of votes in? They seem to be disappearing from my screen. Very good. All right. All right. Let's go ahead and go to the answer. All right. So the answer is C. With declarative code, you specify only the end configuration. You don't define how to accomplish the task. So John, what about A? Why is A incorrect?
So that's almost a correct answer, except you need to replace the word declarative with imperative. So with imperative code, you execute a series of commands in a specific order to reach an end configuration. With declarative code, you don't specify the sequence of commands. You just say, here's what I want things to look like at the end of the deployment, and then the system figures it out for you. So option A would be correct if declarative was replaced with imperative.
Just swap in a single word. All right.
Absolutely.
So answer B, talked about using objects and classes. Now, I'm not a developer by trade. I know, John, you are a developer. So we haven't spoken about objects and classes, but that is tied to, object-oriented programming. All right.
Correct.
So let's go on to question 3. Suppose you're deciding on the type of declarative template to use for your resource provisioning. Which of the following declarative template formats work with Azure? A, a Bicep template, B, an XML template, or C, running a bash script in CLI? All right,
Ooh.
So we've got some votes coming in.
I like some good XML, especially this early in the morning.
All right, getting quite a few votes in. Actually, everybody's participating here. All right, so it looks like everybody was correct on this one. Bicep template, right? Obviously, we didn't discuss.
This was kind of a simple question, wasn't it?
This was an easier one. Yeah, this was an easier one. I'll give you that. All right. So question number 4, suppose you're deciding on the type of declarative template to use for your resource provisioning. Which of the following characteristics is a benefit of using ARM templates? Imperative code, modularity, or management groups? All right. Those sounds like 3 entirely different things altogether there.
Yeah.
Let's see what we get. So
we're getting a bit mix coming through for this one.
Yeah.
That's interesting.
Yeah. Okay, one is clearly taking the lead.
Yeah.
Okay. All right, we're about 70%. Okay,
Mm-hmm.
So all right.
Mm-hmm.
Let's take a look. So modularity, right? So John, why are A and C incorrect?
So ARM templates, even though they're JSON, and even though you probably got the sense correctly that I'm not a huge fan, they are not imperative code. They're still declarative, right? So you're still defining your resources in a declarative template. It's just using a language that is not particularly easy to write. Now, the option C, management group, that's kind of a bit of a left field kind of option there. So that one, really, there's no benefit from a management group perspective of using either ARM templates or any other approach. That's a feature of Azure that you might choose to use infrastructure as code to work with, or you might not. But it's kind of a whole separate thing, a whole separate discussion to infrastructure as code, really.
Yeah,
so modularity is the way to do it.
Yeah, might have been there to throw you off a little bit, because the management group is a feature of Azure Resource Manager, but not necessarily an ARM template. All right. So just to kind of summarize what we talked about today, we went through the process of describing the benefits of infrastructure as code. We talked about the difference between declarative and imperative infrastructure as code, and even had some good questions on it there at the end. And then we dove into what Bicep is and how it fits into an infrastructure as code approach. So again, if you didn't have a chance to follow along with today's discussion, this is a Learn module on MS Learn called Introduction to Infrastructure as Code using Bicep. You can visit that module by going to the link above or scanning that particular QR code. Make sure if you do go there, sign up for MS Learn. It's got an experience tracker as you go through different modules, go through the exercises, and have fun on MS Learn. So John,
and I'll also just throw in one extra thing there, just to plug, because just as an FYI for everybody, Josh actually wrote this Learn module. So please rate it if you enjoyed this talk, or if you enjoy the module, then please rate the module as well.
That would be awesome. Yeah. Thank you for the little shout out there, John. Really appreciate it. And then, John, what's coming up next?
So next week we're going to take this to the next level of detail, right? So we've talked today a lot about the overall space of infrastructure as code, but now we're going to get specific into Bicep. Next week is still a fairly high level kind of discussion around Bicep. We're going to introduce a lot of the Bicep features and kind of do a 101 level introduction into what a Bicep file actually looks like. So we'll start talking about things like parameters and variables and obviously resource definitions and outputs and modules. We won't go into massive detail on each of those things, but we'll look at the kind of how you put together a complete template that uses a lot of different Bicep features. So that's this time next week. You can, of course, look at that Learn module ahead of time if you want to by using the QR codes there. But we really hope to see you again next week. And it should hopefully be me and one of our other colleagues, Stephanie, joining next week to look at how you build your first Bicep template.
And just to let everybody know, John is the actual author of next week's module. So you can go rate that module in advance, give it a good score as well.
Absolutely.
So, but no, seriously, thank you everybody for attending today. We hope you learned something about infrastructure as code, Azure Resource Manager, and Bicep. And with that being said, we will see you next time.
Thanks, everybody. Thanks, Josh.
Bye.
Bye.